All right, let's go ahead and start talking about our lesson today. We're going to talk about two different quadrilaterals today. First off, we're going to talk about trapezoids. We'll do some problems over trapezoids, and then we're going to talk about a rhombus. So let's go ahead and start filling out our flip book here. So properties of trapezoids. We have two different types of trapezoids here, a non-isosceles trapezoid and an isosceles trapezoid. So I want you to think back to triangles. And I want you to think about what did we have anytime we had an isosceles triangle. Well, an isosceles triangle is when we had two sides congruent to each other in a triangle. And we know that the sides opposite of those, or I'm sorry, the angles opposite of those were congruent. Okay, so same thing goes here for trapezoids. Anytime we have an isosceles trapezoid, that means there are two sides congruent. Okay, so non-isosceles trapezoid, no sides congruent. Isosceles trapezoid, two sides. So starting off here at the top, it says only one pair of opposite sides are parallel. Only one side of opposite sides are parallel. So that would be the top and the bottom. These will be called bases. These will be called bases, our top and our bottom. Consecutive non-base angles are supplementary. So I want to pay close attention to what this means when it says non-base angles. If we had all four of these angles here, 1, 2, 3, and 4. Well, the non-base angles here are going to be the two angles that are not on a base together. So remember, I said this is the top base, this is the bottom base. Well, angle 1 plus angle 2 would be equal to 180, right? Because these are not on the same base. Likewise, angle 3 and angle 4, those would add up to 180 as well. All right, now doing this isosceles trapezoid here, it says only one pair of opposite sides are parallel. Only one pair of opposite sides are parallel. Again, that's the top and the bottom, so nothing different there. Then it says here diagonals are congruent. Diagonals are congruent. Non-parallel sides, the legs. So these legs here would be the two sides that are not the bases. All right, so the base would be at the top and the bottom. The legs here are going to be on the left and the right. So hopefully you guys can see that these are in fact congruent, and that's where we get our isosceles name from, those two legs that are congruent. All right, opposite angles. Opposite angles in a trapezoid are supplementary. Opposite angles are supplementary. Base angles, those are congruent. Base angles are congruent. So if we named these four angles here, A, B, C, and D, we would say angle A is congruent to angle D, and angle B is congruent to angle C. All right, so base angles, whenever I say base angles, think about the two angles that are on the same base. Lastly here, mid-segment. So whenever we talk about mid-segment, we're going to have something that looks like this. So we got a trapezoid here, an isosceles trapezoid to be specific. And the mid-segment is going to be the segment here that is in the middle. Pretty fancy terminology, I know. So we got a mid-segment here. We also have, we've talked a little bit about it already, we have a base at the top, and we have a base at the bottom. Okay, so the mid segment is actually going to be the average of the two bases. The mid segment is going to be the average of the two bases. So we could say here that the mid segment was equal to the base plus the base divided by 2. Base plus the base divided by 2. Okay, so those are our properties here for trapezoids and isosceles trapezoids. Let's go ahead and apply those now to our question. So number 9 says, if ABCD is a trapezoid, find each missing measure. Well, we're going to have to use some properties here to help us find this out. Angle B, 76. Angle D, 143. We're looking to find angle A and angle C. Okay, so starting right off the bat here, if I know what angle B is. I'm trying to find angle A. I want to find a property that can help us. Well, this property right here, consecutive non-base angles are supplementary. So the two angles that do not lie on the same base add up to 180. So 76 and angle A here, those are going to be supplementary. So we could say to find angle A, we need to do 180 minus 76. 180 minus 76. So that gives us our answer here of 104. 104. All right. Looking at angle C, we're basically going to do the exact same thing. Okay. We know that angle D is 143. We know angle C and angle D need to add up to 180. So this is going to be 180 minus 143, which will give us an answer here of 37 degrees. All right, number 10. Number 10 is an isosceles trapezoid. So remember, we'll have to use those isosceles trapezoid properties. Angle S, 71. Angle S, 71. We got to find TUV. Okay, well, let's go to our isosceles trapezoid properties. Looks like something that may be helpful for us is if we know what one of the base angles are, we should be able to find another one right here. Base angles are congruent. Okay, base angles are congruent. So if angle S is 71, that tells me that angle V must also be 71 degrees. 71 degrees. So the base angles there congruent. Let's go back now and figure out what we know about the opposite angles. Okay, the opposite angles. Well, the opposite angles here are supplementary. So that means angle V and angle T will add to 180. Same thing goes for angle U and angle S. Those will add to 180. So we could go ahead and do 180 minus 71 here. And that's going to give us 109. So opposite of angle V is angle T, which is 109. So we know angle T and angle V add to 180. Same thing goes here for angle U. Okay, angle U plus angle S is equal to 180. You could also think, hey, these two are base angles, angle T and angle U. We know that base angles are congruent. So angle U would also have to be 109. All right, PQRS is an isosceles trapezoid. Find the measure of angle P. That is for number 11 here. Again, another isosceles trapezoid. Looks like right here they give us two opposite angles. Two opposite angles. Well, in the previous question here, we know that those opposite angles add to 180. So in order to solve for x here, I'm thinking that's really going to be our only option, is to add these two and set that equal to 180. So 11x minus 16 plus 5x plus 4 is equal to 180. And we want to combine like terms here, so combine our x's, combine our non-x's. So 11x plus 5x here is going to be 16x. Negative 16, positive 4, that's a minus 12. So 16x minus 12 equals 180. Got to add a 12 here to both sides. Once we do that, we're going to get 16x is equal to 192. 16x is equal to 192. Last step here would be to divide both sides by 16. And when we do that, we get x is equal to 12. Okay, x equals 12. So that's good to know. We found our x. However, what we're looking for here is the measure of angle P, right? The measure of angle P. So let's think about how we might be able to solve for that. We know that our two values here were in Q and S. Q and S. We know what x is, so we can plug x back in to find one of these angles. But let's figure out here which angle would be most helpful to find. When we think about the base angles of an isosceles trapezoid, so the base angles, well, we know those base angles are congruent. Okay, we know those base angles are congruent. So we know P and S must be congruent to each other. So if we plug x right back in for S, that's not only going to give us angle S, but it's also going to give us angle P. Okay, so we could say, hey, angle P is definitely the same as angle x. So if angle S is 5x plus 4, that means angle P is 5x plus 4. So we say angle P is equal to 5 times our x plus 4. Angle P is equal to 5 times our x, which is 12, plus 4. So Angle P here is going to be 64 degrees. 64 degrees. All right. Number 12. Number 12 says if MNOP is an isosceles trapezoid, find each missing measure. So isosceles trapezoid looks like we've got some sides here. The first side I see that we are dealing with looks like we're looking at OP. Looking at OP, okay? So I got to ask myself, what do I know about these sides of a trapezoid? And remember, if this is the bottom base, this is the top base, these right here are going to be called the legs, okay? The legs. So what do we know about the legs in an isosceles trapezoid? Well, we know that the legs here are congruent. So if one leg here is 11, that means our other leg must also be 11 feet. All right? CO. Look at a CO. So CO looks like it is part of a diagonal. All right, so if we're dealing with part of a diagonal, I'm going to go to one of my diagonal properties. Looks like the only thing I know about the diagonals here are that they're congruent. We know our diagonals are congruent. So if we know they're congruent, looks like this is 8, right? This top part is 8. Well, that means CO is also going to be 8. All right. Our diagonals are congruent, but they do not bisect each other. So the top halves, or the top part of our diagonals are going to be congruent, and then the bottom parts of our diagonals will be congruent. Okay, so if this is 8 and this is 8, this bottom part, if this bottom part's 14, well, the other bottom part must also be 14. Okay, which that will help us find our next question here. They're asking about NP. Well, we just said 8 was the top part, 14 was the bottom part, so we got to combine those two to give us the full segment of NP, which is going to be 22. 22. All right. Last two questions for a trapezoid here. ABCD is an isosceles trapezoid. We're looking at EF. So EF, hopefully you guys remember from the bottom of our properties, is a midsegment. Okay, is a midsegment. So we know that the midsegment is equal to the base plus the base divided by 2. Base plus the base divided by 2. All right, so the midsegment here is EF. So we're going to take the top base, 41, plus the bottom base, 49. We're going to divide that by 2. Okay, so 41 plus 49 is 90. 90 divided by 2 is going to be 45. So EF, 45 centimeters. Last question. Last question. GHIJ is an isosceles trapezoid. Find HI. So we're looking for HI. But it looks like the same type of question as the last one, right? So we can use this formula. Midsegment is equal to base plus base divided by 2. However, it looks like we actually have a midsegment. We're going to be looking for one of our bases. So we're going to do this the same way, but the process to solve for x is going to be a little bit different. So we don't know what this top base is. Let's go ahead and call it x. We're going to use this same exact formula here, our midsegment. So 19 is equal to our top base plus our bottom base divided by 2. So top base is x, bottom base 22, and we will divide that all by 2. Divide that all by 2. All right. Now this right here is normally, one of the spots where we struggle. We don't remember exactly what we need to do here from algebra last year. So the first step in solving for x for this is actually going to be to multiply both sides by 2. Multiply both sides by 2. And that's because our x is being divided by 2, so we've got to get rid of that division. So we would multiply both sides here by 2. So we get 38 is equal to x plus 22. Go ahead, subtract your 22. And we're going to get our final answer here. X, or HI, is equal to 16 centimeters. All right. Moving on to rhombus. A rhombus, okay? So the plural version of a rhombus is called a rhombi. Okay, we got rhombi. That is more than one rhombus. So these first 5 properties you guys are probably all going to notice are very familiar. It's because they are the exact same properties as our parallelogram. Okay, the first 5 are going to be the exact same as our parallelogram. So opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. Hopefully we all know these by heart now, as we have written this down several times. All right, now these last 3 properties here, these are going to be specific to the rhombus. Specific to the rhombus. So all sides in a rhombus are congruent. All sides in a rhombus are congruent. Our diagonals are perpendicular. Diagonals are perpendicular. And finally here, our diagonals bisect opposite angles. All right, our diagonals bisect opposite angles, or if you can't remember, that means cut in half. Okay, so our diagonals are going to cut our opposite angles in half. So I want to think about the properties here of a rhombus versus the properties of a square. So all sides are congruent. Well, that's also in a square, right? Diagonals are perpendicular. Well, guess what? That's also in a square. And our diagonals bisect opposite angles. Well, guess what? That's also in a square. So what's the difference here between a rhombus and a square? A rhombus and a square. Hopefully you guys are picking it up at home. The difference is that in a square, we have all 4 right angles. All right, that's the only difference there between a square and a rhombus. It is a square is all right angles. Rhombus, every single aspect of the square besides the 4 right angles. Okay, so let's go ahead, do some examples here now with a rhombus. So starting off for 5, it says if WXYZ is a rhombus, find each missing measure. So the first thing we're looking at here is XY. XY. So XY appears to be one of the sides of a rhombus. In the previous slide here, we said all sides are congruent. Well, if we know that one of the sides here is 27, that means XY is also 27. All right. Now let's take a look at WP. WP, so that would be this partial diagonal, right? This partial diagonal. So let's go ahead and figure out what we know about the diagonals of a rhombus. So we know that they're perpendicular, but that's not going to give us too much information here because that deals with angles. But up here it says right this, diagonals bisect each other. Diagonals bisect each other. So if you don't remember, bisect means to cut in half. So let's take a look here. We know that half of this segment here is already 21, which means the other half must also be 21. That is 21 inches there. So because we know that diagonals bisect each other, we should know that that is 21. All right, now, next one here, we are looking for PZ. PZ, which is this blue line right here. So when we're looking at PZ, I know that our diagonals bisect each other. So if I knew what the other half of PZ was, XP, I would definitely know what PZ is. However, we don't know what XP is. So let's take a look at what we have right now. Right now we have 21 inches for WP. WZ, well, we know that that's 27 inches because all sides of a rhombus are the same. We don't know what PZ is, but I do know that there's a right angle right here. Right? We know our diagonals are perpendicular, so I know that this is a right angle. Well, if this is a right angle, and I know 2 of my sides, but I don't know the 3rd side, how do I solve that for the 3rd side? Hopefully, everybody at home was saying, hey, Pythagorean theorem, that's what we need. All right, so we will be using a squared plus b squared is equal to c squared. A squared plus b squared is equal to c squared. So that's, again, anytime we have a right angle We know two of our sides, and we're looking to find the third. We'll use Pythagorean theorem. So ABC, which one of those is across from the right angle? C. C is always, always, always across from the right angle. So we can go ahead and put 27 in for C. So 27 squared. Our other two numbers here, 21 and X, does not matter which way those go. Okay, could be A, could be B. It really does not matter. I'll start off with our X. So I'll say X squared plus 21 squared is equal to 27 squared. So now that we have this set up, all we have left to do is actually work out the math. So 21 squared gives us 441, and 27 squared is going to give us 729. So we got some big numbers that we're dealing with right now. We got 729 and 441, and hopefully you can see we need to subtract a 441 from both sides. So when we do that, we're going to get x squared equals 288. X squared equals 288. And remember, anytime we got something squared and we're trying to solve for it, the last step is to square root it. Last step is to square root it. So after we square root 288, we are going to get 17 inches. 17 inches. All right, so I know that's a lot of work, but just remember, anytime we know two of our three sides and we have a right angle, that right angle is very important, we will use Pythagorean theorem. Okay, so the only two shapes you'll probably see this in are the square and the rhombus. Okay, I don't believe we will be using it for any other shapes. So I'm going to go ahead and erase this now, just so we can have a clean slate when we look at our angles. Let's go ahead and start off with our first angle, XZW. XZW. All right, so XZW is right here, which tells me it's part of our angle Z, right? Part of angle Z. So I'm going to go to our properties, figure out what we know about our angles. Well, our third property here says diagonals bisect opposite angles. Diagonals bisect opposite angles, or diagonals cut opposite angles in half. Well, this angle Z, our full angle here, was cut in half. So that means that part of the angle is congruent to the other part of the angle. So if one side is 51, the other angle must also be 51. Okay? So we actually know that both of these are 51. Now we know what angle Z is. The full angle Z here would actually be equal to 102, because you could take 51 plus 51. All right, cool. So now let's look at XWZ. XWZ. That would be this full angle right here. All right. So we just talked about how we knew that angle Z was 102, right? Angle Z, the full angle here is 102. Well, now we need to find the full angle W, okay? The full angle W. So let's figure out what we know about our angles of a rhombus. Right here, our fourth property, it says consecutive angles are supplementary. Consecutive angles are supplementary. So if we know that the angle Z is 102, I can clearly see that angle W and angle Z are consecutive angles because they're right next to each other. So that tells me angle W and angle Z are going to add to 180. All right, so to find angle W here, I know that they're going to add to 180. We have 102 degrees so far, so this is going to be 180 minus 102, and that's going to give us 78 degrees. 78 degrees. Okay. All right. Now, last one here. Looking for ZYW. ZYW. All righty. So ZYW is a partial angle again. And I notice we are right next to 102, and we are opposite of 78. So I know here, if I want to find angle Y, just the whole big angle here, I know that our opposite angles are congruent. right? I know our opposite angles are congruent. So angle Y would be 78 degrees. Well, if I know that the full angle here is 78 degrees, and I know that our diagonals bisect each other, sorry, they don't bisect each other, but that they bisect the opposite angles, well, that means that 78 here is going to get cut in half. Okay, we know the full angle is 78. The angle was cut in half, so that means both of those small angles are going to be 39 degrees. Okay, 39 degrees. Let's check out this last one. Check out this last one here. EFGH at a rhombus, trying to find the measure of angle FGE. So FGE appears to be this angle right here. But we're only given 8x minus 49 and 5x minus 7. Okay. As you can tell, both of these here are right next to each other. And what that means is we have to look at our properties and understand that the diagonals bisect opposite angles. So angle F, this full angle, was cut into two congruent angles. Okay, cut into two congruent angles. So that means that 8x minus 49 and 5x minus 7 are congruent. So we will set them equal to each other. 5x minus 7 equals 8x minus 49. So go ahead, subtract your smaller x. You can get negative 7 here is equal to 3x minus 49. So we have to add a 49 to both sides. This is going to be 42 equals 3x. Last step here, divide both sides by 3. And we're going to get x equals 14. All right, x equals 14. Well, that's good to know. However, it doesn't necessarily give us FGE. We can plug x back in, and we could get this whole angle right here, right? Let's say, for example, if we plugged in, for 5x minus 7, if we plugged in our x, let me do a different color here. If we plugged in here for 5x minus 7, we could get this red angle here where I've got the arrow going. And if we know that that angle was bisected and we multiply that angle by 2, well, that would give us the full angle here of angle F. So 5 times 14 is 70. Minus 7 is going to give us 64 degrees. So here we know that this partial angle is 64. If we are looking now to find the full angle, angle F, we could take 64 and multiply that by 2. Okay, 64 multiply that by 2. So angle F is going to equal 128 degrees. Angle F is equal to 128 degrees. Now the question is, what do we know about angle F and angle G? What do we know about angle F and angle G? Well, angle F and angle G are consecutive angles. So we've already talked about it before. Consecutive angles are supplementary. So I know that angle F, angle G, those two are going to add to 180. We know angle F is 128. So all we need to do to solve for angle G is subtract 128 from 180. All right, so angle G is going to be 52 degrees. But we're not looking for just angle G. We're not looking for that whole angle. We are looking for the partial angle FGE, which is this red, where I'm pointing this red arrow to. Here, we got that blue loop mark on it. All right, so if we know that the full angle was 52 degrees, and we know that this angle was bisected by our diagonal, that tells us that this partial angle is going to be the full angle divided by 2. Okay, the full angle divided by 2. So angle FGE is equal to 52 divided by 2. So angle FGE, final answer is equal to 26 degrees.